Hello, everybody, and welcome to the Microsoft Data and AI South Florida user group. My name is Adriano, your host, and thank you for making the time to be here with us today. And we are very excited for another great presentation. And before we get started, remember to use the live chat to enter your questions and communicate with your fellow attendees. And as we're starting here, please use the live chat. Let us know, where are you located at? Enter your city, your country, and let us know. I So before we get started, as I said, welcome. And remember to like, comment, subscribe, and click that notification bell so you are always aware when we bring in new events. Also, if you have not done so, we have today, at the end of the presentation, we will be raffling a book, Deciphering Data Architecture by James Serra, who is also our presenter today. I will be dropping the link in the chat, in the live chat here, in just a second. So if you have not done so, remember to register for a chance to win the book. Will be a fantastic presentation about the same topic, so you better do not miss out. You only have up to 30 minutes before the end of the session to do that. So I'm going to drop it in a minute, and hurry up, get registered if not so. So back on today's topic, Deciphering Data Architecture by James Serra. And without further ado, here we have, I bring you all, James. Hello, James. How are you?
Hey, I'm doing awesome. Thanks for having me.
All right. Thank you for being here and joining us here. And I see here already on the comment window, we have hello from all over the world. We have Shane from New Zealand. Welcome, Shane. Thanks for joining us. We also have James from Australia. Hello, James. You're getting started right bright and early in Australia and New Zealand there with the presentation. And we have Pablo. Hello, Pablo from Argentina. All right, Pablo. Good evening. All right, and how about you, James? Where are you located at?
I typically I live in Ponte Vedra, Florida, the northeast part of Florida by Jacksonville. I happen to be in Atlanta today for a architect design session for a customer.
All
I'm
right.
not used to this cold weather here.
A bit different for this unusual time, even in Atlanta, to be unusually cold.
Yeah,
And can you tell a bit about your role and how was your journey to it?
sure. I've been at Microsoft 9 years now in various different roles. The current role is as a data and AI architect, where I help customers understand data architectures and in particular building architectures on Azure. So I'll get into a lot of the products that are available for their architectures, but it's all a pre-sales role, which is just knowledge transfer. And I've been involved for many years in IT. I won't go back to my COBOL days, but throughout my lifetime, I've been a developer and a DBA and an architect on the delivery side of things, and now spend my time educating customers.
All right. As you said, you often talking about architecture, and so is the topic today. Can you tell us a little bit about it?
Yeah, this presentation I've been giving for a number of years, when I had a lot of customers who were confused about what do you mean by data lake and data warehouse and data fabric, and so the deck was presented quite often. Probably started maybe 4 years ago, and because of the amount of questions I was getting, I decided this would be good for a book. And that's where the book came along, was based on this deck. And I go much more into concepts and whatnot that are used to build the architecture. So trying to clear up a lot of the confusion that people have, and I try to make it simple to understand. And the book, which will be released in actually about a week and a half now, was something I started back in November. So it's been the previous November. So it's been 14 months of a lot of work and a lot of effort in there, but it's finally at the finish line, and I'm happy to raffle it off and to use this deck as somewhat of an entry point into the book if you wanted to get more information.
Fantastic. And we are also showing here the book on the screen, folks. I will drop the link in the live chat in just a minute. Deciphering Data Architectures, as James just said, today's session, it's an entry point here, and you see the great value, and also you have an opportunity to win it today. So don't forget to fill it up. And without further ado, let's get started. All right, James, you want to add your deck, and we'll be all you.
Awesome. So I will share my screen. Okay. There we go.
Just a second. All right, 2 seconds. All right. All right, James, it's all you. And
great. Thank you. So welcome, everybody. As I said before, I'm James Serra. I'm a data and solution architect at Microsoft. I work in particular in the federal civilian area. So I deal with a lot of government customers in there. Microsoft has everything divided up by industry, like finance and healthcare. And it's very interesting being in this area because a lot of different use cases than you see in the commercial, which I was in the prior 8 years at Microsoft, but a year ago I moved over to the federal civilian. More about me, I've already talked about a lot of this. JamesSerra.com is my blog that you can go and find more information about some of the topics I'm talking about, as well as plenty of others in there. And then, as mentioned, this is my book that's coming out in a couple of weeks. And it's great if you want to learn more about what I'm talking about today. I find a lot of people get confused about all this architecture stuff. So I'm going to try to prevent you from looking like Towley, for those who know South Park in here, and try to clear up a lot of the confusion. And I start with an overview of a relational data warehouse and then a data lake. And then I go into the 4 architectures: modern data warehouse, data fabric, data lakehouse, data mesh. And then I'll talk a little bit about data mesh on Azure. I'll go about an hour, and I'm happy to take questions. So feel free to drop your questions on the chat, and I'll pause at various times, and you can have those questions read to me, and I'll be happy to answer them. If there's things I don't answer, or you have questions afterwards, just shoot me an email, jamesserra3@gmail.com. That I showed earlier, I'll show it at the end. And I'm happy to have follow-on discussions with you and answer your questions in there. I always got to mention that these are the opinions of James, not that of Microsoft. So if you hear something here, and the idea is, don't go back to your work and say, well, Microsoft said this. It's James Serra said this, because Microsoft in a way doesn't really have official opinions on any of this. And it could be different opinions depending on who you talk to in Microsoft. I mean, most of it's pretty close in there, but they're by no means any official opinions about what I'm going to talk about here, because some of it is a little controversial and possibly different views depending on the person. So we're going to start off with the relational data warehouse. This is something that's been around for many years. Back in the 70s and 80s, Teradata and then Netezza were creating solutions that were built. Technology was built strictly for a data warehouse, and then the idea is to take data from all these sources, usually OLTP, online transactional processing systems. So you can have order entry, customer cataloging, customer information. It could be product information, all these different sources. It could be ERP, CRM systems, and you want to pull that information out of those data sources into a central location of a data warehouse using ETL. And there's many reasons for creating a data warehouse in here. And at the very least, even if you're not creating a data warehouse, if you're using some of these architectures that have other storage areas like a data lake for this, you still want to have a copy of the data for many reasons that I list some of them here. Those could be, I want to reduce the stress in the production system. Data warehouses came about because people were doing reporting off of the source systems. Maybe it's a customer system database, and people are entering customer information, and they're doing a lot of inserts, deletes, updates. And here comes somebody along running a report that's overwhelming all of the infrastructure they have, the compute, and the performance of people doing those individual updates, deletes, and inserts was being affected in there. So if we pull that information out of the source systems into the relational data warehouse of a copy, and then have the reporting systems go off of that. You can also organize that relational data warehouse to be more efficient for reading, because the source systems are efficient for writes, whereas the data warehouse is read once, write many. So I can put more indexes for those of you that don't know, or DBAs with data warehouses on there. Stuff you don't want to do in a source system, you can do on the data warehouse in there. You can also make it easier to understand the data by renaming tables and fields from what they are in the source system. So I've dealt with source systems that had table names like R116 and field names that were all these numbers in there. So if you rename them and put them in a data warehouse, you get to the point where you can have self-service BI, where you can have somebody without any technical skills or a big understanding of the source systems can go and create reports, because IT has made it easier for them by doing the things that you see on this screen on there. Because the whole idea is you want anybody in your company to get more insights into data, to make better business decisions without having to ask IT to create these reports and do queries in there. So I can go on and on about the reasons for creating a relational data warehouse. I just touched on a couple of them in there. But this has been the solution for many years with customers who have databases and they want to create reports from them, is go to a data warehouse. About a dozen years ago, Data Lake came around, and Data Lake is an environment that you can land data also, but the difference between a data lake and a data warehouse is schema on write, meaning a lot of upfront work is done to prepare the data to land in there. For example, you will create a database, you will create tables and fields and schemas and do all this work. And then people can start writing ETL to land the data in a data warehouse. With the data lake, it's schema on read, meaning I can land data in a data lake without having to do any upfront work. It's no different than it's like a glorified file system that you have on your laptop, where you just want to copy data into it. That's all a data lake is. It's got more features, and that's why I call it a glorified file folder in there. But in the end, the schema on read means I can dump data in there with little to no upfront work. That data could be more variations than what you find in a data warehouse, which is a data warehouse will have structured data, a relational structured data in there. So there are exceptions, but you generally can't put in things like unstructured data, where it could be JSON data or audio and video files, streaming social media feeds in there. A relational data warehouse generally can't handle that much data coming in. So a data lake can handle all that and more. So that is a main function of a data lake, is ingest a lot more data than you can get in a relational data warehouse. And so the reasons you want to use a data lake is because it's easy to ingest data on there. And a big reason is if you have a relational data warehouse and that's all you have, and you're ingesting data on there each day, generally you'll have a maintenance window. You'll knock people off at night. You'll load all this data in there, which takes a lot of resources in there to clean it also. And then you'll do that in staging tables, and then You'll copy that data after it's been cleaned and maybe joined and aggregated and mastered and put it in production tables in your relational data warehouse. And then you let people back on and cross your fingers, no problems happen. With a data lake, at the very least, you can think of it as taking those staging tables and putting them in the data lake and doing all that cleaning and transformation of the data inside the data lake. So you're using the data lake resources, which would be storage matched with compute, because the data lake is just storage, but you'll take compute, and there's a lot of different options you can use that can pull data from a data lake and clean it and write it back out to the data lake. So you're doing all that outside your relational data warehouse or your enterprise data warehouse. So you don't need a maintenance window anymore. You can run that 24/7. Maybe you'll have a little maintenance window while the data is loaded after it's cleaned, but that's generally a few minutes compared to a number of hours in there. So that's a big reason for using a data lake in conjunction with the relational data warehouse in there. You can also, for those that are technically astute, you can put data in a data lake in a matter of seconds and just tell that end user it's in the data lake, go and generate reports off that, especially if it's data scientists who are used to file format type of environment in there. It's now changed a lot, as I'll talk about with the technology. It makes it really easy for most end users to use a data lake without having to go through a relational data warehouse. But the history has been, and we'll get into the first architecture, where there's a combination of data lake and relational data warehouse in there. Data lakes can also be used to investigate and explore data. Instead of doing all this work traditionally to copy data into a relational data warehouse, and when that's all you had, you could spend weeks putting the data in a relational data warehouse, only to be told by an end users if they look at it, actually that data is not helpful. With a data lake, because you can land data in so quickly, somebody with the technical skills can look at that data and go, actually, this is helpful. And then you can proceed to put it in, and copy it into a relational data warehouse and not waste all that time investigating the data. And you can even hoard data in a data lake, and maybe we'll use it, maybe we won't, because the data lake in the cloud is infinitely scalable and extremely cheap, you can put data in there. Maybe you use it, maybe you won't, but you would never do something like that in a relational data warehouse where you're limited on the storage, and more data in there affects performance. And because the data lake has all those different compute options in there, you can get a lot more performance than you would have a relational data warehouse, which has one compute and it's limited. A data lake, you can fire up huge clusters of data and do a lot of transformations much quicker than a relational data warehouse can do. So those are quick introductions to two concepts, a data lake and a relational data warehouse. And now I'll jump into the modern data warehouse, and then I'll go through a couple of slides, and then I'll take a pause for any questions. So just drop them in the chat now as we go along. So the modern data warehouse has been around, as I said, since probably the 70s. And the traditional flow of data in a modern data warehouse is 5 steps. You ingest data from one or many data sources. You store it somewhere, as shown here in a data lake. So a modern data warehouse is a combination of a data lake and a relational data warehouse. You store it and transform it in the data lake. At that point, you can actually do machine learning off of it. A data scientist may say, that's all I need is data in a data lake. Most times, you will take some or all of that data and copy it into a relational data warehouse, because the end user is used to a relational data warehouse, and you get additional benefits that are not in a data lake in a relational data warehouse. And then you can visualize and do analytics on top of that. So you have data lake and a relational data warehouse. And at a high level, this is the functionality of having both those solutions in there, which are going to have copies of the data warehouse will have copy of the data in the data lake. So the trade-off is that you have 2 copies of the data, and we'll get into the next architecture that solves some of that. But traditionally, it's been 2 copies of the data. I do the staging and prepping in a data lake and other things listed here. And then I copy that data into a data warehouse, which is your serving layer and has a security in there. And a data warehouse traditionally, and still now for the most part, has more security than you find in the data lake. A data lake doesn't have things like roll-up security, column security. So if you need that, you would want to copy that data into a data warehouse, and therefore your data warehouse has that extra security and then becomes your serving layer. So most of the business people, the report writers, will use the data in the data warehouse, where you may have some power users and data scientists who will use it in a data lake. But there's the combination of two that works really well, and it's been using both of them for, I said, about the last 12 years since the data lake came around. Now, the modern data warehouse at a high level, this is what the solution would look like. And I haven't put products on here, so I make this vendor agnostic like my book is, because I can take this architecture and then apply products, whether they're Azure or Google or Amazon, or maybe using some third-party combination of the two. And so what I typically do with customers, like did today, is do an architect design session where I'll ask them a lot of questions, do discovery, and then start writing out the architecture. And if I go to the modern data warehouse architecture, this is what it would look like. Those 5 steps are there again. A little more clarity: when you copy data into a data lake, you will have multiple layers in the data lake. I list them here as raw, clean, and presentation. If you've heard the medallion architecture popularized by Databricks, they have bronze, silver, gold, which is really the same idea. I just rename them something that's easier to understand. And you'll take the data that land in a raw format as is from the source system. You will clean it and land it into the rich layer. You make a conform layer before that, where all the data, which is a CSV, Parquet, JSON, you make conform it all in the Parquet, and then put it and clean and put it enriched. And then you may go to the third layer, which is curate the data, and that it could involve aggregating it, joining it, mastering it, and making it presentation ready. And data lake design could be a long topic, and you need to spend time up front to think through how you want to design your data lake, because it's different for every customer. Depends on the size, the speed, and the type of your data. Some customers will only have 2 layers. Some may have 7, 8, 9 layers in there. And then each layer has a folder structure, which you got to think through, because you want to separate the data out for performance reasons, for security reasons, and whatnot. Now, then you go to stage 4 to model the data. So it's copying into the relational data warehouse in there, and that may land in third normal form. And then you could go into a star schema, where it's easier to understand for end users who go to the visualize stage, which they want self-service BI. So somebody, IT, has gone through the work and created it in this format that's really easy to use, then they could generate reports without getting IT involved. So you may look at this and go, wow, that's a lot of copies of the data. And it is, and more complexity, more cost. But the benefit is the data is in a format that end users can just go and create reports from. So there's that balance of copies of the data and then affording coming up with a solution that is super easy. And this is where it's changing with some of the other technologies, where we're reducing the copies of the data that I'll get into next. And here you'll see the data lake compute. Again, the data lake is just storage. You have to have compute on top of it, and you have a lot of choices with the type of compute you can want to use. And generally, customers will use a combination of products for their compute. All right, let me pause there if there's any questions.
Folks, remember, enter your questions in the live chat. I don't see any questions right now, James.
Okay, good. So let me jump to the second of the 4 architectures. This is Data Fabric. This is where my understanding may be different than others when we talk about Data Fabric. I view it as an evolution of the modern data warehouse. It's adding additional features listed in blue here. So behind basic core is the same as the modern data warehouse, but I'm adding things like metadata. It's a data catalog on there. I may be adding master data management, MDM, on top of it. I may have additional security. I may have APIs that can be used to pull the data in there. All these features take the modern data warehouse and make it a data fabric. The idea is a fabric that goes out and can pull in data no matter what the size, the speed, and the type. So this could mean real-time streaming. This is a little different than Gartner and others may think of a data fabric in here. And sometimes people don't use modern data warehouse anymore. They just call it a data fabric on that, which is fine. But think of data fabric as maybe a newer version of a modern data warehouse in there. And so that architecture, you can see, has additional features than what we had before in a modern data warehouse, and including streaming devices in there, because we come a long way in what big data was. When I first started, big data and Teradata and Netezza was like a terabyte of data. Now my phone has way more than that. And so it's not only batch data where it's coming every night in there, it could be data from social media feeds, tons of IoT devices in there. And a data fabric needs to be able to ingest it. And the idea is to come up with an architecture such as data fabric that'll last for years. So you don't have to go and back to the drawing board and go, oh, well, I didn't think about pulling in this data. Our architecture won't handle it. You want to think through the architecture, spend a lot of time on not only the sources that you're ingesting now, but what you will ingest in the future, so you can handle all that. And this may mean with the data fabric having additional security on top of it. It may mean having a metadata catalog, as I said. So all these things are now have a lot of products in there. And within the Azure world, we have products now, especially with Microsoft Fabric, which can do all of this within one environment on there. But you can certainly mix and match any number of tools to create this architecture.
Hi, James. Just 1 second. If you don't change the slide right now, but you see the data fabric architecture at the bottom, there is the hide button. So Ingo is asking to click on that.
Yeah, there you go. Thank you.
All right, thank you.
And so also pictured here that I was covering up is the data scientists who may want to just go right against that data lake and do some machine learning on there. Because generally, data scientists don't want to go to a relational data warehouse in there. They want to go to the file format, and they may not even want to access the data if it's been cleaned. They may want to go to the raw layer. All right. So let's now jump to the third architecture. That is the data lakehouse, a combination of a data lake and a data warehouse. Somebody got the cute term to call it a data lakehouse. A little bit of history. Back in the 80s, data warehouse came around again. Teradata was the first one. Then came things like Netezza. That was all encompassing, meaning if I purchase Teradata, I have the relational data warehouse storage, the compute, the ETL coding that I'm going to use, reporting, all comes out of one box. And that worked fine for many years. Still, some on-prem solutions are doing that route, but it's very few. What came out in the late 2000s was the data lake. This was at first presented as this magical land of unicorns and fairies and leprechauns that you can put all this data in a data lake and you don't need relational storage anymore. You don't need a relational data warehouse in there. And that failed miserably because a data lake was too complex for end users to pull data out of there, because you had to use things like Hive SQL. And to go to an end user and say, well, your data is in the data lake, go and use Hive SQL, you just get blank stares. And for those customers, and I dealt with some of them who tried to get rid of the relational data warehouses in there, they went back to the drawing board in every use case and went to a modern data warehouse where they combined the data lake. So instead of saying, forget the data lake, no, instead of using the data lake for everything, let's use it for a limited subset of what it was first promoted as. And that would be, as I touched on before, transformations of the data, but we'll use the relational data warehouse for the serving and security layer. Modern data warehouse. Now, data lakehouse, which started almost 4 years ago now, mainly through Databricks, was let's go back to that solution of just using a data lake and not use a relational data warehouse. Well, wait a minute, James, you just said that failed miserably. What's different now? The difference is Delta Lake. Delta Lake is a software that is on top of a data lake. It is not its own storage. It is just taking a data lake and adding this technology called Delta Lake on top of that to give it all these other features that make it relational data warehouse like, with the idea being, with all these features now, I don't need a relational data warehouse. This has come a long way. And at first, when this came about, maybe I would see 1 in every 10 customers, this would work well. Now I would say 90% of customers can get away with not having relational data warehouse anymore and just do everything in a data lakehouse architecture, which is just using a data lake with the Delta Lake on top of that. Now, so what does Delta Lake give you? The first one is the big one. It supports SQL commands like insert, delete, update, and merge. You can't do that with a data lake. It's files. So you can't ingest SQL into it. You'd have to load the whole file into memory in like a Spark notebook and then update it and then write it back out, which could be extremely slow, especially with large files. A Delta Lake allows you to do these individual commands by saving the data, as shown on the right-hand side. If you're in a Spark notebook, instead of saving it in Parquet format or CSV format, you specify Delta. That triggers that software layer to store it a special way behind the scenes. Now, that special way involves Parquet and breaking up the file, and then it has a Delta log to track the changes in there. So right away, that means anything that's going to use Delta Lake needs to support Delta Lake, needs to understand what it is, which fortunately most products now do. But be aware, if you go to Delta Lake route, tools will have to support that. So it gives you those SQL commands. It also gives you things like ACID transactions for a table, which you don't get in a data lake. Other things you don't get in a data lake are versioning. I can now write data, and time travel allows me to go back and say, I'm gonna do a select statement and I want the data as of a week ago, and you'll get that in there. So it's great for rollbacks or audit trails, all that versioning in there. It allows for streaming and batch in one solution instead of having separate solutions for both. It allows things for schema enforcement, schema evolution. As schemas change over time, you can do that instead of a schema changing blows up anything in a data lake in there. And then there's various performance improvements that come out of a Delta Lake. So it's a great solution, and most of the customers that I see in the Microsoft world are using Delta Lake and building out data warehouses, data lake houses, and not having relational storage, not having a relational data warehouse anymore. And at a high level, this will look like, it's just like what we saw from the data fabric, but we've removed the data warehouse component, and the use cases for a data lakehouse then become these 4, solving these 5, I should say, problems that you see with a data fabric or modern data warehouse. Is you have 2 copies of the data in those solutions. You need to keep them consistent, which can be challenging. The warehouse will have a copy of the data that's going to be older. Maybe it's a day old or an hour older, but that could be a challenge. You can get 2 different answers depending on which source you're going to. You have 2 copies of the data, even though storage is very cheap. Now we're saving money. If you have 2 copies of the data, more risk when it comes to security. And then the complexity. Now you have to have people that have to understand both the data lake technology and a relational data warehouse technology in there. So a data lake house is just one technology. It's data lake or Delta Lake in there. And so you make the solution less complex. So at a high level, this is what a data lake architecture will look like. It's just like the data fabric, except the relational data warehouse is replaced by a relational serving layer, which is optional. What this means is it's not a copy of the data, but rather it gives the appearance to an end user that they're using relational data, relational storage, when in fact they're not. This could be in the form of, you can use a SQL view that points to a file in the data lake. You could use Power BI and data sets that creates a model that points to data sitting in the data lake. So it's all passed through with this layer in there. But you generally want to have something on top of the file folder format so end users can make sense of it. I could have 10 files in there that are all related to each other. Well, instead of having the end user try to figure out all that, you create a model on top of that creates the links to all the data in there so they can use that, and therefore they're not having to understand the complexity of the way data is stored in the data lake. Now, everything's got trade-offs. This opens a can of worms. Every architecture, if you listen to vendors, they're going to say everything works great in this architecture, but everything's got trade-off, and you need to find out what those trade-offs are. Some of those trade-offs, by skipping a relational data warehouse, are listed here. I'll just talk about a few of them. Performance. If you have relational storage, you get technologies like advanced indexing, statistics, caching, query plan optimization, materialized views, advanced join optimization, all these things that do not exist in a Delta Lake. So especially if you have relational storage that uses a thing called massive parallel processing. So data queries, reports will go much faster, or at least faster, in a relational data warehouse with that storage engine behind the scenes in there. Now, you may have to look at what is your SLA? Do you need data to be millisecond fast? Is it okay if it takes a few seconds? If that's okay, you can cross this one off the list and say that's all right. I don't need the queries to go fast. Or you come over to the workaround. For example, you can take that data in a Delta Lake and import it into Power BI and have it in Power BI memory, and then reports are going off of that. And that can solve your performance issues, with the trade-off of now you got to schedule an update to that import to refresh it. So everything's got workarounds, but they're come with their trade-offs. Security. There's no rule of security, common security, and whatnot inside of a Delta Lake. Workarounds to that, imported into Power BI dataset, which has rule of security. And then Microsoft got new products like Microsoft Fabric that get around, have workarounds or direct replacements for these concerns on here. So other things listed here I won't go into, but except for the one of the complexity is in a data lake and a Delta Lake, when you land files in there, where is the metadata for those files? How can somebody understand it? Because the schema on read means I don't need to know the schema when it lands in there, but I need to know the schema when I pull it out. Well, that metadata could be in the file as in the first row as the header. It could be in a separate manifest file. It could not even exist. So there's where the challenge is. And this is where you can do things like schema enforcement inside of a Delta Lake to prevent these issues. But another way to do it is to have some metadata layer over there that people go through to make sure that they know the metadata associated with those files sitting there. Where in a relational data warehouse, you're locked in. You have to create the metadata, and you have to go through that in order to get to the data. So two different approaches to getting the metadata. And that's what sometimes it's hard to get used to with people who are used to the relational data warehouse. Is now the metadata could be everywhere. So you have to come up with, think of it as a best practice and create a relational serving layer on top of that so end users can build their own reports. Okay. So let me pause there for questions on that.
Good timing, as we do. We got quite a few, James. All right. So folks,
let's jump into them.
All right. So, folks, remember, use the live chat, enter your questions, and let's tackle here the first one here. All right. This comes from Pablo. Maybe a very basic question, but how to choose the appropriate architecture? Does it depend on the industry, size of the company, budget, or people, and or people?
All of the above. So I'm jumping ahead a little bit just to give you a preview of the way I tend to end this. Is here's an idea at a very high level of when you use each architecture. I haven't gotten the data mesh yet. However, what I list here in bold is most customers are going to use pieces of this architecture. So when I have an architecture design session, like I talked about today, and I go through this in detail in my book of how to do one, the idea is you ask a lot of questions, and based on the answers is where I'm going to decide how that's going to look. Most times it's going to be a data lakehouse, but there'll be exceptions to it. And some of the technology solutions will allow for those exceptions to it. And a lot of times customers have a blend of products that you're going to use. So they maybe they're using a combination of Databricks and Azure Synapse and Informatica and Tableau because that's their skill set. And that's maybe what they paid for licensing Rise. So that dreaded answer, it depends, really comes into play here. Everybody, I wish there was a playbook where I can just ask questions and then go, okay, here's a flow chart. This is the architecture you need. Everybody's different. So I tell customers to go and understand all these architectures I'm talking about, and then pick and choose pieces that are going to work best for you. Now you also have the challenge of everything you know today could be totally changed 6 months from now. So this is where people like me at Microsoft make a living, is explaining not only what's available now to customers, but what's coming out. You may not be aware of it. It may never be announced yet. So I will go into under NDA to customers, here's what's coming out. You can imagine with Fabric, which has been in development for 2 years, a year and a half ago, I was mentioning this to customers about the future, about Lakehouse, about ways to build solutions now to prepare for Fabric. And even now, I'm working with government customers. Some of them are in a government cloud, which does not have Fabric yet. Fabric is GA'd in commercial, but not in government. So I'm talking with them about how to build something in government using Synapse to make the transition easier. So lots of options. It is confusing. That's why we have people at Microsoft. That's why I've created this slide in the book to try to make it, and the blog is try to make it easier for people to understand these architectures and then the concepts behind them so you can build what's right for your particular situation.
All right. So we have a few more here. So next is from Shane. Thanks, Shane, for asking the question, and thanks, Pablo, for asking the question. Does Delta Lake have query caches? Does
Does
Delta
Lake
Lake
have
has yeah? Does Delta Lake have query caches? Does it caches the query? I think that's what it means.
Yes. Okay, got it. It does do that. A lot of it depends on, there's a depends again, the technology that is using the Delta Lake. For example, with Microsoft Fabric, it uses the caching capability of Delta Lake, but then there's additional caching that goes on at the storage level, at the in-memory level. If you're using Power BI, there's different levels of caching. But yes, it does have that built in, and it's sort of there by default. And particular solutions like Fabric will have the cache and automatically check if data's been updated from the source and pull it back in there again. And then you have to understand caches can get flushed, and it's first in, last out, all those things that get involved with it. But a lot of the technology for performance that the Delta Lake gives you is one of them is the caching.
All right. So next question we have from James, and it is from James to James. There we go.
Yes.
So, do you have any advice for people who wants to pursue a career of data architect? Any popular pathways that you saw during your career?
Ah, a a career question, which I love because there's a change of pace, and I mentor a lot of people. And for that person asking, especially with the name of James, reach out to me, and we can have a side conversation on how I got to where I'm at. The short answer is a lot of years experience, I think, is needed to be an effective architect to bring in your experiences being on the other side of building solutions in there, but it's not necessary. You can still be an architect if you get enough experience along the way. I set out when I was a programmer to say, oh, I want to be an architect. So I started, and I was a consultant, so I started taking contracted jobs that would give me experience to different technologies in there. I didn't know, for example, master data management. So I took a project that was using MDM. I didn't know maybe a lot about reporting, so did a project that was on that. So I got all these experiences. So when I'm talking to a customer about architectures, I can go and pick the right product for that particular use case in there. It's just a lot of time spent reading and understanding and having a mentor and reading blogs and reading books and doing all these things. So I felt comfortable. But I will admit, I still have imposter syndrome. Most people at Microsoft do, even though I've been doing this nearly 4 years. Sometimes I will go into a conference room and go, "Oh, are everybody going to go and say you don't know what you're talking about, James?" It never happens, but it's a good thing to have that imposter syndrome because it makes you prepare because you don't want to feel overconfident in there. So even though I've done this a million times, I go and review things so it's fresh in my memory. But happy to have a further conversation on becoming a architect and the career things you can do within your career to get to that level.
All right. Uh, One more, and because there is way more, but let's do just one more for right now. For right now, folks. So don't forget, use the live chat, enter your questions. And the next question comes from Ingo, which is, would you please speak to the difference between data warehouse in Synapse Analytics dedicated pool versus Synapse Data Warehouse in Microsoft Fabric?
Ah, boy, that's a great tough question. The Synapse dedicated pool is a relational data warehouse. It is relational storage with a relational engine. That is gone away in Fabric. Fabric has a warehouse, but the warehouse stores the data in Delta Lake. Everything in Fabric is stored in Delta Lake. No more relational storage. So what's the same is the SQL engine in a dedicated pool and a warehouse in Fabric is pretty much the same, but it's accessing data in relational storage in Synapse, in Delta Lake, in Fabric. So it gives you a lot more flexibility in Fabric to use that data outside of Fabric. Anything that is from Data Lake can use that. And it also makes it easier to switch from one to the other. I can go from Data Lake to warehouse because it's all in Delta format, and I can do that very easily. Within Synapse, you'd have to copy that data from a data lake into relational storage on that. Now, that's the short answer. There's a lot more to it, and the reason why Fabric has a Lakehouse and a warehouse is some of the limitations in Delta Lake. So as great as Delta Lake is, it doesn't support something like a schema yet. That's coming. It doesn't support ACID transactions on multiple tables. So if I have a begin transaction and I want to update a bunch of tables and do a commit, I can't do that with a Lakehouse in Delta format because Delta Lake does not support that. It supports ACID transactions, but only on one table. A lot of people don't realize that. So if I needed that flexibility, I would have to store it in a warehouse. Now, maybe one day Delta Lake will have all these features and you won't have to have a lakehouse and a warehouse. We can get rid of the warehouse. But until that happens, there is still the need for a warehouse. That's a much longer conversation that I give in. And I have a video out there on YouTube that goes specifically into a lakehouse versus a warehouse in Fabric. So you'll probably want to watch that. I think it's 20 minutes.
Fantastic. Thank you very much. And we still have more questions, but folks, we will continue later on. Let's James continue some more of the presentation on the next break. We will circle back. And in the meantime, remember, use the live chat, enter your questions. Also, remember to subscribe, like, and share. Thank you, James.
Awesome. So, final architecture, data mesh. Here's how I try to simplify understanding of a data mesh. Everything I talked about was taking operational data from all these source systems. You can think of them as domains and copying into a central location. Central location owned by IT. Data mesh is decentralized with all the domains creating their own analytical data. So instead of copying the central location and having IT do it, the domains now are responsible for taking operational data and creating that analytical data, whether that's a data lakehouse or a modern data warehouse. So a data mesh is not really an architecture, but rather a cultural and organizational shift. And that shift is to decentralize everything. So think of it as a concept, not a technology. A data mesh can actually be built out using data lakehouse by all the domains. So they can be combined together. But it's a huge organizational and cultural shift. And this is where a lot of customers struggle to implement data mesh because you're just not ready for that massive change. Imagine going to each of the domains and telling them, hey, by the way, don't copy the data to central IT anymore. Go and build it on your own. And that's where a lot of customers have a lot of pushback. There's also a lot of pushback with vendor hyping data mesh. It's not something you can buy on eBay. There's no data mesh in the box. It is that cultural change, and people do not like change. So this is where we have a lot of customers struggle with data mesh. And I try to be upfront with them. Are you ready for it? Is your customer already domain oriented? Is it leading edge? Is it open to a lot of change? If not, then you don't want to go to data mesh route. A data mesh is consisting of 4 principles. This was very confusing. Jamek came out with this data mesh, which was a really great way to combine all these concepts that were not new concepts, but just packaged together really well. And I'm not here to badmouth data mesh, but rather say be aware of all the trade-offs. And if those are okay, then you can go to data mesh route. But too many customers would just start going and building data mesh without realizing those trade-offs. And a lot of confusion from customers was understanding what a data mesh is. So to explain it in simple terms, hopefully, you start with domain ownership. But the idea is the people who are closest to the data understand the best of domains, which could be manufacturer, sales, supplier. They will maintain ownership of the data. Instead of copying it to IT and IT owning it, the domains will own it. So they'll take their operational data, which they own. They'll copy it and create analytical data, which they're going to continue to own. Because if you get into who should clean the data, well, who knows it best? The domains. So domains should maintain ownership and clean the data. Now, along with that comes principle 2, which is domains are going to own the data and they're going to create the analytical data, which means each domain has to have domain teams, mini IT domains. They have to have their own infrastructure, and they have to create the data and the metadata and make it available to others to use. So data as a product. Data, it just means make your data available for everybody else after you create it, your analytical data. And therefore, the data can be shared among all the different domains. Any consumer can go and access it. Now, maybe that means each domain, right, creates API calls that anybody can make to go and get that metadata and the data. So data as a product. And this is the principle that even if customers do not build a data mesh, they'll take this data as a product and they'll use it in a centralized system. Now, if you may be thinking, well, if I have all these domains, which could be dozens if not hundreds of domains, and they're all building their own solution, how can we help them? Well, that's where principle 3 and 4 come into play. Self-service data infrastructure as a platform, number 3, is can a centralized team like IT create scripts that a domain can use to help them build out their solution? Ideally, they run a script that asks what their domain name is, and it creates their storage, their ETL, their security, their compute are all there. Now, the reality is there's very few products that even begin to help with this. Data Fabric does a little bit of this, but maybe it gets to 10%, 20% of that. So this is where a lot of customers struggle because they got to build their own self-service infrastructure in order to shortcut the process of domains building out their data products. In addition, if you have all these domains out there building their analytical platform, they have to have some rules that they all have to abide by. These rules could be, how are you going to clean the data? How are you going to use security? How are you going to model data? These are the regulations you have to follow. So a central team, an IT team, which could be made up of each people from the domains, are going to create these rules that all the domains have to follow, so you have uniformity, because you can't have people going and pulling data from one domain that's got different security than another domain. It'd just be a nightmare. So rules 3 and 4 are there to help rules 1 and 2. So what you'll look like is a combination of decentralized, which is 1 and 2 principles, with the centralized 3 and 4. And this is where it gets very confusing and people kind of lose track. Now, it also gets confusing because I'll see people that say they build a data mesh and they're not following all 4 rules. They may not even be following 3 rules or following the first 2 rules. Can you call it data mesh? Well, probably not, but people want to call it data mesh. And that's where everybody gets confused. They built data meshes, but they're really not data meshes. The use cases for data mesh are these 4 things. I talked about the ownership. It solves that problem. The quality becomes better because the owners of the data are the domains who know the data best. But the 2 biggest reasons for data mesh are solving the scalability problems. If I have central IT and all my data goes there, as I get more and more data, IT becomes a bottleneck. They don't have enough people. They may have technology that can't scale. With a data mesh, each of the domains are going to hire their own IT team. So it solves organizational scaling. The more domains you have, the more people you hire, reducing the bottlenecks, if not limiting completely. Technical scaling also goes away because each of the domains are building their own infrastructure. The more domains, the more infrastructure. Solves the scaling problem. Now that with that becomes a bunch of other challenges, but that's the whole idea of a data mesh, is remove IT from being bottlenecked by making that responsibility happen with each of the domains, who will hire their own people and build their own infrastructure. And you may have an example, many domains. Some customers literally have hundreds of domains. Each of the domains would have products within them, as an example here. So building or even designing all this is a huge challenge, which can take customers many months to do, and involves a lot of change because you're going to go to each of the domains and then you have to say, we're changing things up. You have to move these people around on that, which gets immediate pushback on there. But the idea is to create those domains in order to go the data mesh route. And you may have domains that are source aligned, which people within those domains can understand the way data is laid out, but it could be quite challenging for anybody outside of the domain to understand it. Maybe they don't understand the terminology used. So part of the data mesh process, and particularly Jamek has wrote in her data mesh book, is you can have consumer line domains where, for example, I take supplier and I copy that data into a consumer line domain that's easier to understand for people outside suppliers. You also may have an aggregate domain, because a challenge of having all these domains is if I need to combine data, maybe I'm doing P&L statement and I need to take data from manufacturing and from sales, and I could have dozens of domains. The performance could be a nightmare if I try to combine all that on the fly. So instead, I'll create an aggregate domain that takes all that data, aggregates it, and makes it available to consumers. Now, my problem with that consumer and aggregate domain is, well, now we're centralizing the data. Well, who owns that data? And now that could be a bottleneck, which is kind of goes against the whole purpose of a data mesh in there. And this is where there's a lot of disputes. And this is solved in some parts, some ways, by data fabric, where the big exception of the pure data mesh, I'll call it, is to have storage that is centralized, but logically separated by having folders for all the domains that only they have access to, but the data is in one location. So you solve the performance issues by not having to combine data that could be spread out across the whole world. And you have one area to govern, so reduces security risk too. Who owns that data? It's still the domains. They own their individual folders in there, but you can say that IT owns the whole entire data lake in there. So this is where we have these exceptions, and every customer is using exceptions in their solutions. Concerns about the data mesh, I have dozens of them. I only list a few here. I'm only going to talk about a few of them, and I've touched on, this is a huge investment in organizational change and technical change on there, which right away is a lot of pushback on there. I talked about each domain and have to hire their own people. Well, it's hard enough to find skilled people. Now I got to hire more of them. So if you make an exception, which I see a lot of people building data mesh do, and say, well, instead of each domain hiring their own people, we're going to have IT go and build those data products for each of those domains. Okay, that's fine. But now you're taking away one of the big benefits of data mesh, that's organizational scaling. You're going back to the way it was before. You're going to be constrained by IT not having enough people to go and build these domains. So this is where customers will get to the point where they'll even have shared technical solutions, shared storage, shared compute. Well, now you take away the technical scaling. And so if you take away both of those, you can't really call it a data mesh, because those are the two biggest benefits of a data mesh in there. So lots of confusion comes into play on that. And Jamek in her book, which I referenced down here, says if you don't score medium to high in all these categories, you don't want to go in that data mesh route. And quite honestly, 95% of my customers won't score medium to high on all these, especially early adapter, or being domain oriented already, or having enough organizational complexity that you need a data mesh in there, or a long-term commitment, because data mesh may take you years to build compared to a central solution that you can be done much quicker in. So most customers that I see at Microsoft doing this are already domain oriented, particularly finance and banks, who are also much more tech at core and much more open to emerging technologies in there. What I see as a data mesh future is a hybrid approach. Think of it as a hub and spoke approach, where the customers will start building data meshes for most likely newer data. And because you can't flip a switch and go from centralized to data mesh, you'll have this gradual approach where I'll keep a lot of the data centralized, start building data meshes. I'll eventually start pulling data out of the centralized solution and creating data meshes. And maybe down the road, I'll ideally have everything in a data mesh, but most likely you're not, because all it takes is one domain to go, I'm not building a data mesh. If you want to take my operational data and create analytical data, fine, but I'm not going to do it. I can't keep what I have running as it is. So you likely want to have a combination like this, and that's probably going to be indefinite. And that's my view. That's the way most colleagues view it, as this approach in there. Again, think of all the architectures I've talked about, think through, understand them all, and then come up with a solution that may use a concept or two at a data mesh, but is instead you'll build a data lakehouse, but maybe I'll have domain ownership in that. So I already talked about when to use each. Now, this is very high level. Most customers are going to use a combination of all these architectures. And then lastly, and then I'll open it for questions, just a few slides of data mesh and on Azure, because again, data mesh is a cultural organizational shift. It's not about the technology in here. So in Jamek in her book, she doesn't mention any technology in here. I'm just going to talk a little bit about using Fabric to build a data mesh. They don't even really call it data mesh inside of Fabric as much, but the ideas are the same. In the Fabric world, they take the domains. You take workspaces inside of Fabric, and those become domains, and one or more workspaces will be put under domains. So that, I would say, is solving option principle one in ownership, is those workspaces, but you have to do a lot of work to make sure the people who access those workspaces are the domain people, and that domain design is what takes a long time in there. And so when I list here the four principles, it solves partially ownership, doesn't really solve much of data as a product, really doesn't do anything for principles 3 or 4. So data mesh, Microsoft Fabric helps with the data mesh. You can say it helps principle 3. If you standardize on Fabric, that'll become your infrastructure platform. But the trade-off is now you're limiting it. You can't have each of the domains using their own technology, which would be the pure data mesh. But every customer has exceptions, and they limit what each domain you're going to use. And you just have to. And so you have in Fabric this one lake. I touched on this before. That's a huge data lake that each of the domains will use. Instead of having their own data lake, they will create a lake house or a warehouse, which is simply a folder inside of one lake, which is a central location for all the data, but logically separated out into different data lakes in there. But technically, they're not separate storage areas across the country or the world. And then, this is what the one lake gives you: the ability to have a data mesh and solve the performance issues because the data is all located close. There is the ability to have shortcuts within one lake to use as a virtualization layer. So these domains could actually be another lake somewhere if you wanted to go that route. Maybe you also have data laws that data can't leave a country, and you can have shortcuts to it. The trade-off then is if you need to join that data together with other data, you're going to have to bring it together at some point, and that's where you may have performance issues. So a lot of resources. I'll make this deck available for you to dive more into it. And there you go. If I don't answer your questions now, shoot me an email, and I'll be happy to answer the follow-up. But I'm happy to stay on now and get to some of those questions. I know we went kind of a little bit over.
And that is fine, James, for relating the time. And yes, we got quite a few questions, and then we have the raffle as well.
All righty.
All right, tackle a few of the questions here. All right, and first of all, folks, thank you very much for entering your questions. Still time to enter the question. Use the live chat. Also, remember to subscribe, like, and share. On to the first question. Here we have from Noman. Do you see Microsoft Fabric as a complementary to Delta Lake architecture, Databricks, or Is it more like you have to choose one or the other?
Yeah, that's an easy. They're complementary. And this is something I go into other presentations, but with Fabric, everything is stored in Delta Lake. That means I could use any product outside of Fabric that understands Delta Lake. Well, obviously, Databricks understands Delta Lake, they created. So I can build a solution in Fabric, and then I can jump outside of Fabric, go into Databricks, and Databricks can point to that one lake and use the data. And as an opposite is I can have data that is stored in a data lake in Delta format through Databricks, and I can create a shortcut to that and then pull that data into Fabric. Either way you go, as the data gets updated, it's updated in real time because you're providing shortcuts to the data, not separate copies of that. So with a lot of customers, they may want to do part of their solution in Fabric, and they might want to do part of their solution in Databricks. The underlying storage is Delta format. And this is the beauty of Microsoft Fabric is unlike some other competitors of Microsoft, it's open source. One Lake is open source, so anything you do in Fabric can be used outside of it.
Fantastic. All right. Next questions we have from, I hope I pronounce correctly here, Ariwa. And the question is, to what degree does security inform a company decision to pick one data architecture over the other? Is it necessary to keep data secure, but not to overwhelm the client? So pretty much how much,
Yeah,
yeah.
yeah. I wish we could all trust each other and not have security, but the reality is much different. All of the architectures now, no matter which one you're using, you have to put a lot of time up front for data governance. You have to think through the type of data, how sensitive it is PI data, and then take appropriate steps to secure it. You can use any security in all these solutions in here. Some of the products make it easier. With Microsoft Fabric, they're coming out with, in a couple of months, something called One Security. This allows you to put security on top of the data, and no matter what product you use, it's going to filter through that security. This is called One Security. It's a big game changer. So if I think of row level security, column level security, dynamic masking, those kind of things, I can do that in certain environments. I could be in a SSMS, and I can, using T-SQL, and I can create that security on top of the data that's sitting in a Delta Lake and when I'm using Fabric in there. However, that works great if somebody is using that interface, that relational engine. But if somebody says, I'm going to access that data through a notebook in Spark, they're bypassing that. So in the notebook in Spark, I'd have to create row level and column level security. All these environments, I'd have to create that security. In Fabric, you create the security once, it sits on top of the data, and no matter which product you use, inside or outside of Fabric, it's going to go through that security. They all have to be using Azure Active Directory. So that's the trade-off, or whatever it's called now, Entra ID. But once that feature is implemented, which is going to be in a few months, then it makes life a lot easier. But regardless, you have to have a governance team that's going to go and tell people that you have to create row-level security in there and set that all up. So I always tell customers to spend a lot of time up front on data governance, have a center of excellence team, have the right people in there. The last thing you want is some data breach on that. So think through all that, come up with best practices, because you can have all this great technology, but if people are not following best practices, it's not going to be worth anything. It's like having a door with a great lock, but you have to close the door and tell people to close it.
All right. So in the meantime, we have another question here from Gina. I would love to know a case study of a successful data mesh.
I would too. So so it's kind of humorous in a way. There are success stories. Microsoft does. I think I have it under resources here. I'm not quite sure if I put that in there. Maybe not. But we do have, and I'll add it to this slide. We do have some use cases on them. There's not a lot because there's not a lot of customers that have built a data mesh. Because it takes years, most of the customers who've even built one are only partially through. Maybe they have a dozen domains and whatnot. And then there are solutions that are categorized as data meshes where you may go, I don't know if that's really a data mesh on there. Microsoft does have it. Some of that I can't share, but there are dozens, we'll say, even in the hundreds of customers that have built what I would call a data mesh. And most of those are financial customers in there who have standardized on Synapse and Fabric as their technology that they're using for all the domains. I've interviewed a few customers out there who have publicized their data mesh solution, but in most cases, I came away saying that I don't think that's really a data mesh. And when I go to presentations that I give for user groups in person, I usually ask people how many people have built a data mesh in production, and I haven't had one single person raise their hand yet. But they are in there, and if you really wanted to know, and you're a Microsoft customer, those can be provided to you.
All right. Next question we have Pablo. When you were referring about a cultural change, is that from the data guys or from the entire organization?
The entire organization, because think about it. If I have an IT team and there could be 100 people and they're ingesting all this data and they're building analytical data, we're going to go to them and say, you're no longer building analytical data. All the domains are. So what I've seen happen with customers is those IT people will get moved to those domains because the domains need to hire people. Well, why not hire somebody who's already in the company? Then you have each of those domains. They usually broken out by business functionality, which could be related to the solutions they're using. Maybe they have ERP systems and CRM systems, but you may have duplications and you may decide to consolidate that into one domain. So you're going to have a lot of people moved around. So now you have all that change going on in there. So that's cultural change. And this is where you get a lot of pushback. And this is where a lot of customers start going down the route of a data mesh, but they realize it's going to be so much change. It's too drastic and they're not ready for it. So IT will change drastically. And a lot of times those IT people that are not pushed out of domains become in charge of principle 3 and 4 of building out an infrastructure that each of the domains can use, of be putting on a team that's going to come up with the standards that everybody's going to follow, the federation approach of providing global rules that each domain are going to implement, but also sometimes that central team will implement for the domains in there. So there's generally a combination of it. Ideally, you want the domain teams do it all, but sometimes IT will do it on that. So that IT may remain to do that. So, but it's a drastic change. And I can't stress enough how much of a cultural change the data mesh is.
All right. We have a new question here from sorry, 1 second. All right. Gina has another question. That's a good one. Does your book touch on architecture techniques for large organizations that have grown through acquisitions of only loosely related companies?
my book solved the problem for everybody. No, I'm just kidding. I talk about federated solutions in here, and that's where I clarify in the book it's different than a data mesh. I've had vendors say, well, use our virtualization software and link up all the data lakes and data warehouses, and that's your data mesh. Well, that does not solve any of the four principles in there. It provides a federated solution, but the domain ownership is still with central IT. The data as a product is not being solved at all. You're just putting a virtualization layer on top of that. But that could be very useful if you don't want to create a data mesh, but you want to have, in this case, you have a lot of these organizations that through acquisitions have all the separate data, and maybe you don't want to centralize all of it. Maybe some of it, but not all of it. This is where Fabric really shines. Fabric has the idea of shortcuts. So I can pull data in one lake, but I can also have shortcuts out to data. So one lake through shortcuts is a virtualization layer and that a lot of customers are using. And I'm very impressed with when I demo that. So I can have local data with a combination of shortcuts. So in that situation where I have all these acquisitions, if I don't want to copy all that data centrally, I just provide shortcuts to their data. There's trade-offs. If they have data that's not clean, well, what are you going to do? You have to pull in unclean data or try to clean it on the fly. They may have data that needs to be mastered. Well, I can't do it if there's shortcuts. I got to collect the data and run it through a master data management solution and all that. So you got to think through all those things. But a federated solution could be an answer with something like Data Fabric and shortcuts that's not going more extreme into a data mesh. And yes, the book goes into more detail on that.
All right. And next we have FrickFrack76. if your if your current infrastructure uses Synapse and Azure Data Factory (ADF), what advantages to move to one lake can offer?
This is, I would say, outside of the scope of this presentation, and I give other presentations that go into detail on Fabric, but I will answer it at least briefly. Is there's well, in fact, I'm just going to pull up a slide that's going to go through that one. I have this Microsoft Fabric deck here, and one of the first slides is to answer that question: why use Fabric? And this is all the reasons here over Synapse. This is top reasons to use Fabric really over Synapse in there. The one lake and the shortcuts, as I talked about. There's the idea of universal capacities, which gives you universal compute on there. There's Fabric being a SaaS solution, software as a service, compared to a PaaS solution that Synapse is. Very few knobs to turn. Everything's auto-tuned and auto-optimized and auto-scaled on there. It's built on top of Power BI. So citizen developers as well as IT will use Fabric to build a solution instead of having Power BI for the citizen developers and Synapse for the IT on that. So that's just a few of them. You really get blown away when you have Copilot that's available in Fabric and not in Synapse. And so those are just some of the reasons. I will say every customer that I've demoed Fabric is saying we're going to go with Fabric and over Synapse, especially if they've not started down the path of Synapse.
All right. I think we have. We still have questions. This This question is a couple of questions together. First question is, what is the upcoming security feature called One Security? Is it in preview? And do you know if it will support encryption at rest?
it will support. So that's a follow on to. I had a slide here for one security. Pretty sure it's here. Yeah, there it is. Whoops. This is the one security, and it is not out yet. The timeline, which is public, we have for everything in Fabric. You'll see here, we've published, which Microsoft has never done before, what's on the roadmap. And this is, they don't say one security in here, but it is one security. And that's coming in the Q2. So in a few months, that'll be what I talked about before, taking the security on top of the data. And it, by default, everything has security and REST in Microsoft. If you wanted to go one step further and do things like TDE, that'll be part of the one security. And yeah, in short, it's not in public preview yet. You have to wait a few months for it, but it will be a big game changer.
And the follow-up question too is kind of you cover potentially, will OneLake Security support something like SQL Server always encryption? Example, encryption in motion.
No, see, the challenge is you could be pulling data from all different sources, and those sources may not understand that type of encryption. So nothing that I've seen on the roadmap for that. I can see the big challenge though is because of every destination would need to decrypt it. So I would say I don't ever see that happening in there. However, there are plenty security features that you can argue you wouldn't need that by the way the data is secured at rest and in flight. And that would be something I would get the security guy at Microsoft to go more in detail in, because I'm not well briefed on the security in flight, but they do have it. It's just not it's not the same thing as the SQL server, which you're asking, always encrypted. It's something different.
All right, and for now will be the last question before we go to the raffle. And this last question comes from Damu. Thank you, Damu, for the question. How long will it take to adapt to a data mesh for an organization perspective if they are already doing BIDW? So how long will it take to adapt? Go ahead.
Okay, I'm assuming meaning if you already have centralized data and you want to go and switch that out to a data mesh, it's going to take a while. That is why I stressed start out with a couple of domains and say, well, maybe I'm getting new data, and that new data, instead of landing in centralized, I'll create a data mesh in there. Or maybe I'll pull out a few centralized sources of data, and I have those domains that are more open to a big cultural change, and start with them and see how it goes and learn from them, and then start adding more data meshes in there. You're going to spend probably a year just preparing for it all. You can argue that maybe within a few months I can do a sort of a POC or some pilot that's going to do some of that, but it's going to be limited in principles 3 and 4. It's going to take some time to build out some infrastructure as a service and to come up with all the global rules in there. So you may start out small, and maybe you're doing a little bit of built infrastructure, a little bit of the global rules in there. You're doing a little bit of data as a product, maybe not going full-fledged. And then each time you create another domain, you do a little bit more, a little bit more. So you're getting something out maybe in a 6 months time frame on there. But I can't stress enough, you have to think through this. How am I going to design this? How the domain's going to look? So I don't have to go back and go, oh, I didn't think about this, and now I have to go and redo things. So that's where You just have to spend a lot of time, if nothing more than you have to get everybody trained up on what a data mesh is and how are you going to make this approach on that. And so that's going to take a number of months on there. So this is where a lot of customers go, we don't have time for that. We have this big backlog of features we want to implement. We can't put them all on pause for 2 years while we go and build the data mesh. So another reason why customers don't go down the data mesh route in there. So hopefully that gives you some idea. I don't want to, again, say I'm bad mouthing data mesh. It is an awesome solution if your company is ready for it and has a long, what is called, a long airport runway to go and build it.
Yeah, the what the Damu mentioned here is like, so for future, I think it means implementation, you start with the data mesh and peel the onion for the older data
Yeah.
and then integrate incrementally.
Yeah, that's exactly what I was trying to explain here, and I probably didn't do a great job of it. But you'll still need to, before you even get to that point, you'll still need to do a lot of planning on that. I mean, and I tell a colleague of mine, Pete Hine, he's got this book that just came out a few months ago that goes into a lot of detail on the data mesh. He wrote this before, the first version of this before it was called the data mesh, and he updated it to use the term data mesh and had some more of his best practices that found. But this book is great, and you'd want to have everybody in your staff read this book, discuss it, come up with centers of excellence before then you say, okay, now let's go down to the path of creating a pilot that's going to build out a few data meshes.
Fantastic, great information. All right, folks. Thank you all for the questions. And now let's engage here with the raffle. So what are we raffling? 2 seconds. All right. So today we have James' book, which is Deciphering Data Architectures. Thank you very much, James, for making the book available. Appreciate that. And let's get to share. Let's get to share. Oh, what did I do? Stand by for a second. Let's get a sharing here. All right, here we are. We already have all the names entered. But what we're going to do first is let's do a little shuffling. And how many books, James, we'll be shuffling for?
Well, it's if you're okay with the ebook version, I can do a handful. For those that want a hard copy, I'd probably limit it to 2 or 3. I'll see how much I can get the publisher to send that out, but I would say at least 3. And the book will be available in about 2 weeks as an ebook, and then within 1 or 2 weeks after that as a printed book. So it just depends on what you prefer.
Tom, I do not. All right, let's go digital because that's easy. Probably easier to make it available.
Yeah.
Tom, just a quick one, Tom. I do not see your name in here in the list of entries, though. Just so you know. That's why it's not displayed here. All right. So, all right, folks. We did the shuffling. You got the names. Let's click to spin. And let's click on it. And the first one, so we're going to do First winner is Shane. Congratulations,
Awesome.
Shane. Take a note on that too. So we're gonna do 3 books, and what I'll do is, like, on the next session, I'll do 2 more, and that will make 5. Is that okay with you,
Yep, that
James?
works.
All right. So Shane. So folks, if you do not get in today, I will open a, a new form, and you can try on our next event, which I will be coming out for February. I'll be announcing in a couple of days. All right. So right now we have Shane, and let's remove Shane's name, and let's do another shuffle. Let's click to spin. Now, second book goes to Mauro. Congratulations, Mauro. You get a digital copy of Deciphering Data Architecture from James. All right, let's remove the name. And now, folks, drums run. Let's do another shuffle. Hide, click to spin, and Miguel. All right, congratulations, Miguel. Okay, folks, let me change this. All right, there we have it, folks. Thank you very much. And Fernando, it's a separate registration, just so you know. It's not on Meetup. It's on a form. The list, sorry, and so folks, it's a separate form that you have to sign up for that. And remember, we will have it again next user group meeting in February. You will see it announced in the next few days. So you still have a chance to win next time. All right. James, thank you very much. Really appreciate the great amount of knowledge you just shared here with us, as always, with the community out there. And also, folks, remember, the book, yes, it is right now on a raffle, but it's also coming out in print. You will be able to order the book as well if you want to get a print copy, you know. And James will be available in February, March timeframe.
Yeah, and it's actually supposed to be due the February, I think, 8th. You can on Amazon you can pre-order the print version, and then within about a week you'll be able to pre-order the ebook, and it should be then shortly after that you can you'll get the ebook.
So everyone can get right now in Amazon and pre-order the book.
Yes, you can go in there now and pre-order it. And I always got to say, the price you see there is the retail price. It'll drop, and you are guaranteed. I don't know Amazon did this, but you're guaranteed to get the newer price. So you'll essentially get refunded the money of the difference on that, and it's just the way Amazon does things. And
Fantastic. So
hopefully
don't
for
get
people,
sticker shocked. Beware.
yeah,
You're gonna get a discount to the book.
yeah.
All
Or
right.
you want to play the full price? That's fine. I'll maybe go on a world tour with Stephen King, but generally technical books doesn't get anybody to that level.
All right. And thank you very much, James. Thanks everyone for attending. Remember, it's understandable that there is a lot of great information that James shared here. do not be shy. Come back, review the sessions, start looking at your preferred session or section you want to learn more. I will work on and put in a bookmark so you can, as you come back over and over, you can go to the specific session that James presented. All right. And if you haven't registered yet, remember to register to the Microsoft Data and AI South Florida. The link is below in the description of of this video. Also, if you have questions after it has been completed, we have the comment section where you can enter your questions as well. And that's all there. Anything else you want to add, James?
That's it. Thanks everybody for attending. If I didn't get your question answered, you think of something afterwards, just shoot me an email and I'm happy to follow up.
All right, James, hang on just a second. And thank you all. Have a great night and good day, wherever you are at. And see you next time.